Hello everyone, let me introduce myself before start the 3D video. My name is Albani Johanes with NIM ending 022. Here's the 3D graph, the example of database. But did you know what graph theory is? Graph theory is a branch of mathematics that deals with the study of graphs, which are mathematical structures consisting of vertices and edges connecting them. As you can see in this database graph, we have the vertex and edges. The edges is the database that like the one in the circle, and the vertex is the one on the arrow. This example is database can be a graph that we know they are connected each other, but there was a database that connected by using cloud computing to connect the database to the other device like server and the other. After the explanation about graph theory, now let's continue to the 3D video of graph theory. So this is the example of drawing K33. As you can see, this is the relation between vertices and edges. But before we start, we should know what is K stand up for. K is stand up for Kuratowski theorem, or we always said as K is a fundamental theorem of graph theory. So Kuratowski's theorem states a graph that we made, so there is denoted as K33, and the graph is only 3 for the graph, as you can see in the circle. But in the circle we can say that as bipartite graph in 3. So after the graph, let's talk about the vertex and edges completely. In graph theory, a graph is a collection of vertices, also called nodes or points, and edges, also called links or arcs, connecting them. A vertex is a fundamental unit of a graph, and it represents a single entity or object. An edge is a connection between two vertices, and it represents a relationship or interaction between the corresponding entities. Vertices and edges can have various attributes or properties that describe their characteristics or relationships. An edge is a connection between two vertices, and it represents a relationship or interaction between the corresponding entities. Vertices and edges can have various attributes, but this hop isn't to optimal graph. An optimal graph is a graph that satisfies certain optimization criteria or objectives. The specific definition of an optimal graph depends on the problem or application at hand. Optimal graphs are important in many applications because they provide efficient and effective solutions to complex problems. If this graph be optimal, we gonna move the vertices that make a cross until this graph have less cross. So we gonna continue the 3D video. Let's back to it. So this is the graph that have only less cross, or it's say one cross. So because this optimal draw, we know this graph is a planar or non-planar. A planar graph is a graph that can be drawn in a plane without any edges crossing each other. A non-planar graph is a graph that cannot be drawn in a plane without edges crossing each other. So we know that this graph is a non-planar, then we can't do formula or verify. One famous theorem, Kuratowski's theorem, provides a simple criterion for determining whether a graph is planar or non-planar by checking for the presence of certain subgraphs. So all drawn is complete from the database to the normal drawn, and now the optimal drawn that says this is a non-planar graph. So this is the end of the 3D video. With database, and the next video is the behind the scene of my 3D design. Thanks for watching.